6 steps in hypothesis testing, population proportion, problem 3. Let's begin by reviewing the 6 steps in hypothesis testing. Step number 1, we state the null, the alternative, and type of tail. Step number 2, we state the predetermined significance level, alpha. Step number 3, we calculate the value of the test statistic. This comes from the sample data, and since we're doing proportions, we use this Z formula. Step number 4, we calculate the p-value, and that will come from either using a table or using technology. Step number 5, we determine what the p-value indicates, so that will be the decision of the hypothesis test. If the p-value is greater than alpha, we fail to reject the null, or if the p-value is less than or equal to alpha, we reject the null and conclude the alternative. So when the p-value is low, H of O must go. In step number 6, we state the conclusion of the test in clear English. Here's our problem. According to Nielsen Media Research, of all the U.S. households that own at least one television set, 83% of them had 2 or more sets. A local cable company campaigns the town to promote a new cable service found that out of 540 households visited, 482 had 2 or more television sets. At the alpha equal 0.05 level of significance, is there sufficient evidence to conclude that the proportion is different than the one reported? So our first step is to label the information we're given in the problem. 83% is our null hypothesis. Now we know this because of the keyword all. So this is a statement about the population. Parameter p, and this is not coming from a sample. The sample size was 540. X is 482. Alpha level is 5%. And the alternative is the proportion different than the one reported? So this is what we call a two-tailed test. Step number 1. For this example, we are given the null. P equals 0.83. The claim is the portion is different than the one reported. Is the proportion of households that own at least one TV set is different than 83%? So from this claim we can write the alternative. H1, P is not equal to 0.83. We don't care if it's less than or greater than, we just want to see is there a statistically significant difference. Step number 2, alpha level is 0.05. Step number 3, from the problem we know that X is 482, N is 540, and our sample proportion is X over N, which rounds off to be 0.8926 to 4 decimal places. Step number 4, we're going to calculate the p-value. Step number 5, we will make one of 2 choices. The first choice, fail to reject the null. Second choice, rejecting the null and concluding the alternative. If we fail to reject the null, we state there is not sufficient evidence for the claim. If we reject the null and conclude the alternative, we state there is sufficient evidence for the claim. Step number 6, we always state the alpha level first. Then we state if there is sufficient evidence or there is not sufficient evidence for the claim, and we write the claim in terms of the problem. So let's use technology to compute the test statistic and the p-value. Using StatCrunch, we go to Stat, Proportion Statistics, one sample with summary. We type in X, number of successes. We type in N, number of observations. We type in the null, 0.83, and then for the alternative we choose a not equal to. We hit compute, and we see the test statistic is 3.87. The p-value is 0.0001. Mini-tab, we go to Stat, Basic Statistics, one proportion. click Summarize Data, type in X, N, check Perform Hypothesis Test. We type in the null, 0.83, click Options, make sure the alternative is a not equal to, and then we click Use Test and Interval based upon normal distribution. Click OK, and we see in the session window our test statistic, and the p-value is 0.000. So it is a positive number, but rounded to 3 decimal places, it rounds to 0.000. Using the graphing calculator, we hit the Stat button, use our right arrow key to move it over to Test, then number 5, 1 proportion z-test. We state the null, 0.83. We type in our X and our N. We choose not equal, and then we select Calculate. There's our Z, our test statistic, and this is the p-value. This is in scientific notation, so we would say the p-value is approximately equal to 0.0001079. Using the table 5, we want to know what's the probability that the Z is greater than 3.87, our test statistic. Of course, this is off the table chart, so we use the default of 0.9999. Since we want the area to the right of a positive 3.87, we take 1 minus that value and we get 0.0001. Because this is a two-tailed test, we must double the area. Because we found the value of greater than 3.87, now we need to find the value of a negative 3.87 because we're doing a two-tailed test. So the probability that Z is less than a negative 3.87, again, that is off the charts, so we use the default, which is 0.0001. And since we have a two-tail, we could simply say 2 times the value of one of the tails, as the normal distribution is symmetric. So according to the table, the p-value is 0.0002. So any of these values for the p-value will work in our step 4. So using our outline, step number 1, the null is p equals 0.83. The alternative is p is not equal to 0.83, and this is a two-tailed test. Step 2, the alpha level is 0.05. Step 3, the test statistic, the null p is 0.83, x is 482, n is 540, and p hat is approximately 0.8926. So if we throw these values into this formula, we're going to verify what the computer gave us, which is Z rounded to 2 decimal places is 3.87. Step number 4, the p-value comes from the test statistic. Since we have a two-tailed test, we're going to double the area of greater than 3.87, and the p-value I'm going to use is from StatCrunch, 0.0001. This will help us determine the decision of the test. So we say because the p-value equals 0.0001, which is less than alpha, which is 0.05, we reject the null that p is equal to 0.83, and we conclude the alternative, which is p is not equal to 0.83. So the conclusion of our test, number 6, we would say at the alpha equal 0.05 level of significance, there is sufficient evidence to support the claim that the proportion of households in this town who own at least 2 TV sets is different than 83%. Thanks for watching.